And we're ready to do some more graphing. This time, it's graphing systems of equations. So take your pretty yellow foldable and open up to example 1, please. If you look at example 1, you see that we have a system of equations. And you say, what is a system of equations? Well, here we have two equations that, because they're together, and sometimes they're written with a fancy brace like you have on your foldable, it says y equals 2x plus 1 and y equals a negative 3x plus 1. One of the ways that you can solve systems of equations is through graphing. So remember that we talked about when we do y equals mx plus b, remember that m is our slope and b is our y-intercept. Okay? So what we have to do with both of these equations is we have to graph them on the same coordinate plane. So if we look at our first equation, we know that our y-intercept is 1, and that's where we have to start. So I'm going to put a point here at 1. Next, we have to use our slope, which is 2. Remember that when it's 2, that's the same thing as saying 2 over 1. So we are going to rise 2, and we are going to run 1. So from our y-intercept, we go up 2 places, and then we go to the right 1, and we put a point. Okay, we could go down 2 places, and this time go to the left 1, and here we have another point. Or we could just continue the pattern up like we were before, okay? But at this rate, I'm just going to connect our points with our arrows, okay? Next, we're going to graph the second equation. On the second equation, again, our y-intercept is at 1. So I'm going to put another dot there. And our slope is negative 3, which means negative 3 over 1. So from our y-intercept, we are rising negative 3 and we are running 1. If we are rising negative 3, that really means we are going down 3 spaces. So 1, 2, 3 down, but then we go 1 to the right. If we go back to our y-intercept up here at 0, 1, we can go up 3, 1, 2, 3, but instead of running to the right, we run to the left. And we can put a point there. Now, when we are looking for the solution to a system of equations, we look at where the two lines intersect. At what point did the two lines intersect? They intersected at the point of 0, 1. So 0, 1 is our solution. What does that mean? That means that if we go back into our first equation and we plug in 1 for y and we plug in 0 for x, we know that 2 times 0 is 0. 0 plus 1 would give us 1. So that shows us right there that that is a solution for the first equation. Now we do the same thing for the second equation. We plug in 1 for y, we plug in 0 for x, and again we get negative 3 times 0 is 0, 0 plus 1 is 1, and so again it works in both equations. That's why 0, 1 is the solution, because when you plug in the x value and you plug in the y value in both equations, you're going to end up that it checks out. Okay? Now let's look at example 2. Remember that in order to graph an equation, we must have the equation in slope-intercept form, y equals mx plus b. So my first question is, are these two equations in the slope-intercept form? Is it in the form of y equals mx plus b? No, it's not. This is in what is called standard form. If you remember from our video last week, standard form. That's the ax plus by equals c. We need it to be in our slope-intercept form. So in order to do that, we have to solve for y. So if I take our first equation, 5x plus y equals 4, and I start solving for y, in order to get y by itself, I'm going to have to subtract 5x from both sides. When I do that, I end up with y equals a negative 5x plus 4. Remember, we cannot add the 4 and the negative 5x because those are not like terms. So now we have an equation in slope-intercept form. Now we look at the second equation. It's also not in slope-intercept form. So I am going to do x minus y equals 2. And again, we have to solve for y. We have to get y by itself. So first thing we do is subtract x from both sides. When I do that, I now am left with negative y equals a negative x plus 2. Remember that in front of a variable, even if there's not a number, we know that there is a 1 there, correct? Now how are we going to get y by itself? Well, we have to divide by negative 1, but remember we have to divide every term by negative 1. So negative 1 divided by negative 1 just gives us a positive y, or 1y. Negative 1 divided by negative 1 would give us a positive 1x. And then a positive 2 divided by a negative 1 would give us a negative 2. Now I have two equations that are in slope-intercept form. If we go to our first equation, our y-intercept is at 4. So we're going to go to our y-axis, plot our point at 4. Next, we have to use our slope. Our slope here is negative 5. That's the same thing as a negative 5 over 1. Remember, it is rise over run. So if it's a negative 5 rise, that means that we're really going down 5 spaces. 1, 2, 3, 4, 5, and then we have to run 1. That's a positive 1, so we go to the right. And I can go from there down 5, 1, 2, 3, 4, 5, and I can run 1 from there. And there's another point. Okay, I now take and connect my points with a line. Next, we are going to graph y equals x minus 2. Well, we know that our y-intercept is at negative 2. So we're going to go to our y-axis to negative 2. We know that our slope, remember, we have a 1 in front of that x. So that means we are 1 over 1. So that's rise over run. So if I start at my y-intercept here at 0, negative 2, I'm going to rise 1 and go to the right 1. From that point, I am going to rise 1 and go to the right 1. And I can keep going and going and going. Here, where do our two lines intersect? Where does our red line and our blue line intersect? They intersect at the point of 1, negative 1. So our solution then is 1, negative 1. If we go back and plugged in 1 for x and negative 1 for y, it will check out in both equations. Pretty simple, huh? We're really not doing anything that we haven't already learned. We're just showing how to find the solution when you have a system of equations. It's basically just where the two lines intersect. So we will be practicing this tomorrow and the following on Monday in class. So I hope you have a good evening, and we will see you in class tomorrow.